Today we are going to continue domain and range. The first question is find the domain and range of function fx equal to 2 cos 3x plus 5 plus 7. Actually here our function is fx equal to 2 cos 3x plus 5 plus 7. First of all we are going to discuss about the domain. If you substitute x equal to any real number from minus infinity to plus infinity, the value of cos 3x plus 5 is going to be any number from minus 1 to 1, a finite number. The value of cos 3x plus 5 is a finite number, even a finite number from minus 1 to 1. That is why, since this one is the finite number into 2 is again a finite number, and plus 7 is again a finite number. So value of fx is neither going to be infinite nor indeterminate nor imaginary. It means any real number x satisfy the condition to be domain. So the domain of this function will be, domain of function f will be all the real number. This can be also written as open interval minus infinity to plus infinity. Once again, we know that cosine function have value, finite value. Cosine function of whatever the angle is, the value of cosine function is from minus 1 to 1, a finite real number from minus 1 to 1. And cos, there is no root, there is no upon denominator. 2 times cos 3x plus 5 is again a finite real number, and even plus 7 is a finite real number. So for any real number x, the value of fx is going to be again a real number. That is why the domain of this function is whole real number, minus infinity to plus infinity. Now we are going to discuss about the range. As I told you, cosine 3x plus 5 always lies from minus 1 to 1 in the closed interval minus 1 to 1. Let us multiply it by 2. Therefore minus 2 will be less or equal to 2 cosine 3x plus 5 is less or equal to 2. We have multiplied this one and this one by 2 and have got this result. Now we are going to add 7 to all of them. If you add 7 to this, minus 2 plus 7 will be plus 5, less or equal to this will be 2 cosine 3x plus 5 plus 7 will be less or equal to 2 plus how much, 7 equal to 9. We have added 7 to this number, minus 2 plus 7 equal to 5, 7 to this term as well, plus 7 and 7 to this term, so becomes 9. Now we can see that this 5 as it is, less or equal to as it is. In place of 2 cosine 3x plus 5 plus 7, we can substitute 2 cosine 3x plus 5 plus 7 is the fx. fx is less or equal to 9. Thus we have come to the conclusion that the value of fx is from 5 to 9, and this one is the range of the function. So the range of the functions, required range of the function becomes closed interval 5 to 9. That's the question. Now let us move to another question one. Another question is find the domain and range of domain and range of fx equal to 2 plus 3x when 2 is less or equal to x is less than 3. It is x when 3 is less or equal to x is less than 4, and x plus 1 when 4 is less or equal to x is less than 5. We are going to find the domain and range of this function one. As you know, domain of function is the value of x. It means the set of the pre-images. The set of x is the domain of the function. We have discussed a lot about it. Now let us see from where to where does x vary. In this question, the x is from set of integer. Now we can say here in the first range, the x varies from 2 to 3. And how many integers are there from 2 to 3? Integers, not the real numbers. We are discussing about the integer one. We are going to find the domain and range of this function, and function is defined on the set of integers. Now we can see that here x varies from 2 to 3. So there is only one integer, it is 2. 3 is not there. In the second one we can see that the x varies from 3 to 4. So there is a single integer 3, not 4. And in the last one we can see that the x varies from 4 to 5. There is the single integer 4. So we can see that all together there are 2, 3 and 4 involved, which are integers. So domain of this function is set of those integers 2, 3 and 4. Once again I am going to tell you from the beginning. Here the function f is defined on the set of integers by the formula this one. In the first range, this range of x, value of fx is 2 plus 3x. In this range of x, value of fx is x, and in this range of x, value of fx is x plus 1. We are going to discuss about the domain first. Domain is the set of pre-images. It means the value of x we are going to choose from here. We can see here x varies from 2 to 3. X is greater or equal to 2. Here x equal to 2 but not equal to 3. So only one integer is seen there. It is 2. The second one, we can see there is only one integer 3. This one is the smaller than 4, not equal to 4. That is why only 3. And the last one we can show that there is the integer 4, not 5, because less than 5. So domain of this function is all integer involved from here to here is 2, 3 and 4. That's the domain of the function. Now we are going to discuss about the range. Range of function f is, first of all, substitute x equal to 2 in the function. It will be f2. And where does 2 lie? 2 lies here. So we are going to substitute x equal to 2 here. Actually, range of f is value of f2, value of f3 and value of f4. Set of f2, f3 and f4. Now we can see there where does f2 lies, because it is 2 lies in the first this range one. That is why f2 becomes 2 into 3 into 2. 2 into this one becomes 2 plus 3 into 2. Second one f3. 3 is here, that is why f3 becomes just 3. And finally f4. 4 lies here, that is why f4 becomes 4 plus 1. This one is 4 plus 1. So range of this function is 3 to the 6 plus 2 equal to 8, 3, 4 plus 1 equal to 5. This one is the range of the function. Once again from the beginning, this is the function fx defined on integer. Don't forget, this function is defined on set of integers. So only integer can lie on the domain of this function. Here, once again let us see from the beginning. Here the function fx is defined on the set of the integers. So only integers can be there in the domain of the function. Neither the decimal number nor fraction nor another real number other than integers. Here we can see that x varies from 2 to 5. X is greater or equal to 2, and here greater or equal to 3, here greater or equal to 4. So continuously, if you combine all of them, we can see that x is greater or equal to 2 but less than 5. That is why in the domain the integers are 2 is there, after 2 3 is there, after 3 4 is there, but it is less than 5. That is why 5 is not there in the domain 1. So the domain of the function becomes set of 2, 3, 4. If you substitute x equal to 2 in the function, it becomes f2. Substitute x equal to 3, then f3, likewise f4 in the range of the function. But as we see, 2 is here in the first range 1. So the value of f2 becomes 2 plus 3 into 2. We replace x by 2, the first one. Likewise f3 becomes, because 3 is here, we replace x by 3. That is why the value of f3 is 3. Likewise 4 is here in this range 1. That is why value of f4 is 4 plus 1 equal to 5. That is why we are able to say that the range of this function is 8, 3, 5. Okay. Let us move to another question one. Find the domain of fx equal to under root x minus 2 plus under root 5 minus x. If this type of question comes, then we find the domain of separately domain of these expressions. First of all, we find the domain of this one. Then second, we find the domain of this one. As we know, here we cannot put a number smaller than 2. For the domain of this function, we simply make x minus 2 greater or equal to 0, because this cannot be negative. If it is negative, then the result becomes imaginary. So it is not less than 0. Not less than 0 means it is greater or equal to 0. From here we can say x is greater or equal to 2. X is greater or equal to 2 means x is right of this one. So this one is closed interval to infinity. So the domain of this expression is closed interval to infinity. Likewise, if you apply the similar process here, for the domain of this expression one, it becomes 5 minus x is greater or equal to 0. So we can say 5 is greater or equal to x. So we are very easily we can say that the domain of this function is such a real number which are less than or equal to 5. Less than or equal to 5 means there will be 5 in the real line. All the real numbers of this side, and they are from minus infinity up to 5. So we are able to say that the domain of first expression one is closed interval 2 to open infinity, and domain of second expression one is minus infinity to 5. Now we have to find the domain of this region one, because out of x is this plus this. So to find the domain of this region one, we take the intersection of both of these intervals. The intersection of this interval becomes from 2 to 5. We can see very easily the first set is this one and second set is this one. What are the intersection? Common region is from 2 to 4, 2 to 5. So required domain of our function becomes closed interval 2 to 5. That's all.